Okay, so what we are doing today's lesson is something that is going to be on our first mid-unit assessment, which is next Thursday and Friday. Remember, this is like an actual weighted grade, okay? And it's going to cover this lesson and then the one that we'll start with next week. Today's lesson is an Algebra 1 lesson. You have learned this before. I know it's been like 2 years, but you have learned this before. Where we really get into something brand new is on Tuesday, Wednesday of next week. And that one, it's a lot of writing, so be prepared. But it's not bad. So like I said, Delta Math, we will be working on, I think, maybe 6 problems to do, and that'll be your homework. So again, I might kind of skip through some of the notes since we have pictures in this class, and I don't know how long that's going to take. As far as what I had y'all do last class, kind of your homework, if you will, I did post this all on Canvas, my answer keys. So we did a lot of this together. A-Day, I was really able to go through a lot of stuff with you. But if you kind of want to look and check, this is page 3. If you wanted to check any of your answers, if you haven't already, they are here. We might have done the whole first page. I'm not sure. I have 4 Algebra 2 classes this year, so I'm not always straight. I know we talked about some of these, and I know we talked about the fraction one and dealing with the fractions, and we'll practice more on that today. Remember, it is possible to get fractional solutions. Doesn't always look pretty, but that's okay. What I wanted y'all to look at, though, on these next couple of pages was, and we were kind of in a rush, so I don't know if I explained the directions all the way, but we can talk about it now. Or you may not have known you're supposed to do it. It's okay. We're all good. But page 5 and 6, these are, as we get into systems of equations, and again, this is something you had learned before. These are situations where we are going to do some that are already set, like the equations are there, and you just go. Substitution elimination is what we're talking about here. But we also have word problems. So these 2 pages, if you didn't do them, maybe go back and look at them. I don't need you to circle the answers. This is on Canvas. I don't really care about you getting the answer. I care about you knowing how you got it. But it wanted you to kind of go through and read the situations and circle the incorrect one. So the ones that are circled are not set up correctly. So this is a perimeter situation. The reason it was wrong is because when you're doing perimeter of a rectangle, you have 2 lengths and 2 widths. So I just corrected it right there. But this other equation was set up right. So that's kind of the flow of that. But I will say in this unit, it's usually the word problems that trip people up. And when you get to your mid-units and your summative, there are going to be word problems that you set up and solve. If you set them up incorrectly, your solving is all wrong. Now, I talked about partial credit and how I look at that. If you mess up the setup, I can kind of try to follow your work from there. But it also might really stress you out because if you do have an incorrect setup, you might be getting crazy answers. And then that typically makes people it's a red flag. So you probably should go back and look at that again. But you can see, and even if you just want to look at mine on the key, why is this one right? Why is this one wrong? Okay, so I gave just some general notes. We will do several word problems throughout the next couple of days. You also have, where am I on? This is page 6. We've got 2 we're going to set up in the notes today. And then just to point this out to you, on page, I should know this, but I don't. Page 21. When you start on page 21, it's kind of in there as its own lesson, but honestly, it's just a bunch of word problems. Your Delta Math, the next couple days, is going to have you go work some of these problems and then put your answers in Delta Math. So that way you can practice with those. So we've got tons of word problems for practice, but I just kind of want to plant that seed for today. You got to know how to do it, and they can get pretty complex. Some of them are really easy, okay? But that's where we are, and that is kind of the goal of this unit. So I've got 2 minutes before we're going to go down for pictures. So let's just go ahead and talk about what it means to even be a system of equations. Kind of already said it. What it is we're on page 7. Page 7, okay? Pencils out, ready to go. So a system of equations is you're going to be solving things that have more than one variable To do so, you need to have more than one equation. So today's focus is 2. We're going to have 2 equations. We're going to be finding 2 variables, finding what their values are. When you solve linear systems of equations, you're pretty much finding the point that those lines intersect. This is Algebra 1. You probably spent a lot of time in Algebra 1 actually graphing these and putting the point that they cross. We're going to just stick to the algebra side. Substitution, elimination, are any of these words familiar to you? Hopefully, okay. So, but just as an intro, here's kind of what we're doing. We're trying to find our 3 different cases in which you can have a solution, a point of intersection between 2 lines. Most common is case number 1, a situation like this, and where your lines cross one time. So you would say that there is one solution. It will be an ordered pair, and that's where you get the value of the x, the value of the y. But that is most of the time you will get 1 point. Okay. However, there kind of are those special cases, just like on the solving that we did last class. And we looked at that one where our x's zeroed out. And we were left with 3 equals 3. And I was saying true or false. And y'all said, oh, that's true. So we had all or infinite solutions. That is case 3, which basically, there's my alarm. I'm going to finish talking about this, which is basically this is the all or infinite solutions. If you do the all real number symbol, that's fine too. I kind of prefer infinite solutions or all solutions for this. But basically what this is, I'm going to kind of do this. It's the exact same line. So they share every single point because they are the same. So that's the 3 equals 3 thing. No matter what input, they're always going to have the same output. So that is a possibility, and we'll see that. But again, it's more common that you're actually going to get 1 point. And then our last case is our, how can you describe these lines? No solution, but they're parallel. So this is a no solution situation because they are parallel, they're never going to cross. So they have the same slope, but they have a different y-intercept. So in Algebra 1, you spend a lot more time talking about the graphs and kind of what it means and everything. We're focused more on the algebraic solving, but I just kind of want you to wrap your head around, like, what are you doing? Why do you write your answers as an ordered pair? Why do you need 2 equations? That sort of thing. And we're going to leave it at that. And we're going to go look pretty for our pictures. And then we'll come back and get through the rest of this. Back to it. So we kind of talked about, like, what it means to solve a system, why we're doing this. We understand that. Now, here's how we do it, okay? So we're going to go over 2 methods. For 2 variable systems. You are going to have 2 variable systems. Again, this is an Algebra 1 thing, but we are going to have you do some of these on your mid-unit and on your summative by both methods that I'll teach you. I don't believe that the summative, whatever, assessments say you have to use each one, but we'll talk about when is best based on how the problem is set up. But majority of the new stuff is the 3 variables, which we'll get into next class. But first method is going to be substitution. Basically, it's in the name. You take one of your equations. To use substitution, you want to have one of your 2 variables isolated. Is preferred. If it starts like that, I do substitution. And then you sub in the expression into the other equation for that variable. And then you plug back in and solve. That's in words. Let's see it in action, okay? So I know that I can use substitution in this problem. I have x isolated in my top equation. I have y isolated in my bottom equation, so you get choice. Let me preface this too before we start in this entire unit. With systems, there is a lot of routes that you can take and get to the same answer, especially next class. So depending on how you start step 1, your work may look entirely different than mine, but we all get the same answer and we all did it right. So some people like that you have a lot of freedom. My advice is always to try and take the easiest way out, okay? What is the easiest way? What's going to do the less work for me? And that's typically the route that I will go. And we'll talk about how to defer between that later. But I also will say, depending on, like when you're working, especially next class, I'm going to do a couple with you and then really let you guys just kind of spend that time working. If you get stuck and call me over, it's going to take me about 5 minutes to like see what you did and follow through that. So please, please, please be organized, especially on things that I grade. Okay? All right, that was my little spiel. Here we go. I'm going to start by subbing in. I'm going to use the top equation. What I do is I will usually box what variable I'm going to sub in for. So I'm subbing in 22 minus 4y in for x right here. Kind of draw an arrow where it's going to go. And then I'm going to rewrite that second equation, subbing in my expression for x. So I have y is equal to 9 minus 2, open parentheses because you have two terms to go in there, 22 minus 4y. Why we did that? When you have one equation with two different variables, you can't solve and find an actual numerical answer. The second you get the equation in terms of the same variable, you can solve. It's just going to take a little bit of cleanup, but this is like problems that I gave y'all last class. So we go through our steps: distributing, combining like terms, variable to one side, constants to one side, solve. So here we go. Distribute through here. This is also supposed to be done non-calculator right now. So negative 2 times 22 is negative 44. Negative 2 times negative 4y. Positive 8y. Do I have any like terms to combine?
Negative 44 and 9.
Combine to be?
35.
Want to do that very first. Now I've simplified both sides. I need to get the variable to one side. Smarter to move the 8y because there's only one constant and it's already by itself. So how do we move the 8y? Subtract it over. And this will give me y minus 8y is negative 7y. It's okay, you guys. How I just did, you see my work? I didn't show that I was doing minus 8y. I'm okay if you do some of this in your head, okay? But if you need to write it out, write it out. I'm just going to be pressed for space. And then to get y by itself, I divide by negative 7, and y is equal to 5. Okay, did we find the whole solution?
No.
Not yet. Okay, we have done the bulk of the work, but we are not finished. We just found the y, so now we need to go back and we need to find the x. So we need to use that. With substitution, I always go back to, it truly doesn't matter, smarter not harder, go back to the one that your box is around because that's going to be the variable that you're looking for and it's already isolated, so this is easier to plug in here. Not the only way, it's just easier. X is equal to 22 minus 4 times y, which we found was 5. 4 times 5, 20. 22 minus 20, x equals 2. And so I want you to write this as your solution is the ordered pair 2, 5. You'll write your solutions, unless it's a word problem and your variables actually like stand for something, write them x, y as an ordered pair, okay? One thing that's great about solving, I don't know if I talked about this last class, but solving equations in general, when you're finding that solution, you're finding out what numbers, numerical values are going to make these guys true. So you can check your work. You could go in and you could plug in x and y into both of these equations, and you should get true solutions for both. It takes time, but you know, if you've got time and you're finished with your tests and you want to be like, I want 100, go plug in your numbers and make sure that they work, okay? But that is an option there. Let's look at number 2, okay? When you look at the setup with substitution, I'll make a note of this. With substitution, you need one variable that's isolated. Do y'all know what I mean when I say that?
Yes, ma'am.
Also, I kind of write all over the place and tend to like skip stuff too, so you'll learn. It just kind of how I go. So when you look at your equations and you see that like either x is by itself or y is by itself, top or bottom, left or right, doesn't matter. But if I look at number 2, I can see, oh, this equation, y is isolated on the bottom. So that would tell me, hey, substitution is going to be the smarter way to do it. Okay, not the only way, but we want to work smarter, not harder. And so we're going to start with that. But I also look at this equation, and I don't love that fraction right there. And I kind of talked about this last time. We need to know how to clear out our denominators. So if you look at a problem, and you will be looking at problems with fractions on them, the first thing I would do, manipulate the equation to make those fraction or plural go away. So what can I do to get rid of that 5/2? multiply the whole thing by 2. This one's kind of nice because there's only one denominator of 2. I would not suggest converting to decimals. Okay, I don't like decimals. I prefer fractions over those. So what I would do is I'd take this entire equation and just multiply by that one denominator, which is 2. If you have multiple denominators, you need to find the least common one between that. But in this case, it's pretty easy. So I'm just going to double that entire equation. So when I do that, 2 times 5 over 2 is going to be, remember how to multiply fractions? 2 times 5, 10. Over 1 times 2, 10 over 2 is 5. Or you can see right there, the 2's are going to simplify out. That should happen. So 5x. Now make sure you multiply everything. Minus 2y equals 2 times 2, 4. So I would now say, okay, I'm going to ignore that equation that was in ink. I made it look just a little bit prettier. And now I can go forward with my substitution. So I'm going to box 3x plus 1. I'm subbing it in for, hello, they're just here to annoy me. Saw enough of them last year. I don't know why they're here now. Okay, so we're going to sub in this expression for y right there. And then I'll do my rewrite, and I'll have 5x minus 2 times 3x plus 1 is equal to 4. So you're good if you now have an equation. It's going to need to be cleaned up. It's probably going to have several steps to do that. But if you look at that and you say, hey, this whole guy is in terms of x, you've done your substitution correctly. Go ahead, find x. Ready, go. Another kind of like side note on these. It is 1,000% possible to get, like in the scheme of life, to get solutions that are not nice, pretty whole numbers, okay? Totally possible. Lines can cross, and they don't have to cross at like a nice little whole number. However, when you are doing something non-calculator, hear me out. When you're doing something non-calculator, if you get that x is equal to 111 over 95, might be a little bit of a red flag there. Okay, is it possible? Yes. Is it likely that I'm going to give you something like that on a non-calculator test? No. Okay, I mean 1/2, all right, we can deal with that. But something like real wild like that, that might be okay, let me go back and check my work. Here's the other thing with this. If you make a mistake on the first variable that you solve for, what is going to happen to your second variable? It's going to be wrong. So, that being said, this little step right here where I have my arrow, while that is not a lot of work to do and a lot of work that you can do in your head, please show me that so that way if I can say, ooh, they missed a negative, I can at least know that you know what to do next with your wrong number. And I won't count them both wrong. Yes? Oh, I was going to say, did I do something wrong? I just checked my answer key over here, but it is definitely possible. This next one, I think some of you guys are kind of already working on that. It is set up for substitution as well. I'll go ahead and start it down here. Anybody notice anything weird on this one? You gotta... Do you, though? Did you multiply correctly? You just... Oh, like before you even started? You could do that, but again, what's easier? Work smarter, not harder. Y is already by itself, so I would start there. Okay? Yeah, when you're doing substitution, I would always start with the one that is by itself. But what happens in this situation? What's negative 6x plus 6x? Zero. Remember, when your variables drop out, we talked about what it means to have a solution at 0 versus no solution, all solutions. If your variables are gone, in this case, they are gone, you're left with 14 equals 10. True or false? So this is a no solution, and that's what you would say. I would make sure you know what this means and how to interpret it. I would feel like it's a red flag if you turn in a assessment and you got everyone as a no solution. Probably a red flag, but definitely make sure you practice interpreting those and knowing what that means. Yes? Do what? You have a what? Quick poll. How do we feel about word problems?
Kind of enemies, kind of friends. Matters in my mood.
Okay, hear me out. Hear me out. Word problems are tricky. I know. The more of them you do, the easier they will get. But again, when it comes to assessments and stuff, if you can't get this set up, you are not going to solve it correctly. Okay? So we have to know how to do that. So this is Algebra 1 level. But it does help with writing, which whether you take it Algebra 1 level to Algebra 2, it's still writing. You have to know how to take a situation and convert it into math language. So let's look at this first situation. You have Karen here. She's got $4.60, and she has that made up of dimes and quarters. There are your variables, okay? So we can call them D for dimes, Q for quarters. If you want to do X and Y, I don't care. I am going to ask you to label your variables. You can write me something pretty, D equals dimes, or you can do what I did and just write it in the problem. Just make sure I know which is which, especially if you do X, Y, Z or whatever, I need to know. Do not use O. I'm telling you things not to do. Do not use O as a variable because that looks like a zero. If you're going to use T or L's, do capitals because they can look like pluses or they can look like ones. Speaking from experience, that's really annoying. So, but this one is fine, okay? So when it comes to writing these, you are writing 2 equations at minimum. Next class, we'll be writing 3. So we need to come up with an equation about the fact that she has $4.60. Then we need one about the number of dimes and quarters. Understand, D represents the number of dimes. Q represents the number of quarters, okay? And if you're confused at what your variables are, look at the question. How many dimes? You want to know the number of dimes, not the money value. So there's 2 numbers in here. There's 460 and then there's 10 more. Let's start with the 460. I think that's easier. 460 is a money value. So to get that total money value, we have to add up the money value of dimes and the money value of quarters. What's the money value of a dime?
10 cents.
10 cents. So I need to put that as 0.10 or 0.1. You don't have to put the 0. D. So 10 cents times the amount of dimes we have plus quarters, 0.25, and that's equal to $4.60. This is the money. Money value, total money value. If you kind of look through my answer key for the ones that were wrong, let me show you one that was wrong. Like this one. This was the wrong equation. You don't have to flip over, but just look. Because it said dimes plus quarters equals 665. That doesn't make sense. This is a number of coins equal to a money value. That's not right. It's got to be money. Okay? So when you have your money value equation, you got to put that there. Then we're done with 460. The other number we need to use is 10. These are the ones that trip people up. So here's how I explain this. She has 10 more quarters than dimes. What are we talking about? What's the subject? What came first?
Coins. What number of coins?
Quarters.
Okay.
Quarters. 10 more quarters. So that is how I'm going to start my next equation. Quarters is equal to more than or less than represent addition or subtraction. More than means we're going to use an addition sign. Okay? Now, here's how I work these problems, because with the more than, it doesn't matter. With the less than, it does, and you need to know this. Whenever I see a more than or less than, I call those a switch word. So the number, whatever comes before the word more than, needs to come after the sign. So plus 10. Whatever comes after dimes, in our case, needs to go first. With addition, it doesn't matter. D plus 10 is the same thing as 10 plus D, right? Right? 5 plus 4, 4 plus 5. 5 minus 4 is not the same thing as 4 minus 5. So if it says less than, if you do not switch that, wrong. Everything is going to be wrong. So I just say get in the habit. If you see a more than or less than, that's a switch word. I'll write it down. Switch word. And I would switch that there, just meaning the number is going to go at the end, and then whatever you're talking about is going to go there. But the kicker is if you get the wrong variable at the start, It's a mess. Okay, so the way I think about it is, what is the subject of that sentence? What am I talking about? What comes first? That's the one that needs to be by itself. Okay, you also can kind of plug in some numbers. You need to have more quarters, so you have to take the number of dimes and add to it. That's what makes there more. And this would be set up for substitution. For time purposes, we'll come back and solve this if we have time. Non-calculator, I'm not going to give you decimals on a non-calculator. So if we do solve this, I'll do the calculations up here. But I kind of want to give y'all time to do your Delta math and practice. Setting up, though, is like what's the tricky part with it. Solving it isn't bad. Okay, let's talk about our next one, which is elimination. We'll do a couple of these. We'll set up a word problem, and then I'll show you what Delta math I want you to do for today. Okay? Elimination. What are we saying that about elimination or Delta math? Well, y'all are gonna love it. It's gonna be great. Okay, elimination. Have we heard of that? Yes. Here's what I will say about elimination. Next class, when I teach you guys how to use 3 variables, or how to solve 3 variables, 99% of it is elimination. So, in my opinion, I don't want to say substitution is not important. You probably are going to see something that you need to know how to do substitution, but when it comes to 3 variable, it's this guy that we need to know. So, with elimination, our goal is to, you can use this when you have both equations in standard form. What does that mean? What is standard form? Where are x and y? Same side. Same side, okay? So it's like something x, something y equals constant, okay? That's when I would use elimination. You also want them to be like in a line. X over x, y over y, number over number. This would be the perfect setup for elimination. Could you use substitution? Yes. Smarter though. Not going to be smarter to get this isolated for one variable. Then your goal is to, again, here's your choices. Choose one of your variables. It's up to you. Right now you got 2. Next class you're going to have 3. So you choose what's going to be easier to eliminate first. To eliminate, we have to create a 0 pair, which means we need the coefficients of one of our variables to be the same number, but opposite signs. Okay, I always do elimination by adding. I strongly suggest to do that so you don't lose signs here. So when I look at this, I've got a 6 and a 3. Can I turn, I always start with the smaller one. Can I turn a 3 into a 6?
Yes, ma'am.
Okay, pretty easy. So that might work. Let's look at the other one just in case. 2 and a 3. One's negative. Okay, so I have opposite signs. That's kind of helpful. But can I turn into a 2 into a 3
No, ma'am.
by multiplying by a whole number? No. So what's smarter, to take out the x or the y? Take out the x. That's what I think. Is that the only way? No. But we're going to eliminate x. So there's our note. I always like to write what I'm eliminating so you kind of know where my head is going. So if I want to take out an x, I need to turn this 3x into a 6, but what kind of 6? So what am I going to multiply the whole equation by? -2. Okay? I'm going to rewrite the top guy. 6x minus 2y equals 20. Multiply all 3 times. Do not forget the constant. That is like 9 times out of 10. If I have a mistake, it's because you forgot to multiply the regular number. Okay? Okay, after you do that, you're in a situation where you're ready to add these guys up. What happens to your x's? They zero out. They zero out. Bye-bye. Okay, -2y plus -6y is -8y. 20 plus -36 is -16. So what is y equal to? 2. Are we done? No. So I think elimination, you have to reason through and think about what's the best way to solve it or to start it. But when it comes to finding your second variable, this takes more work than substitution because when you do elimination, both of your equations are in standard form. So at this point, it's truly, again, up to you. What do you think is going to be easier to plug back into? I would go into the original because the coefficients will be smaller. But you pick whichever one and then solve for the other variable from there. I would probably think that 3x 3y equals 18 would be what I pick because there's no negatives, but it doesn't matter. So go back, plug in for y. It's also really important that you guys don't lose your variables because this happens a lot in Algebra 1. We'll get a number, and I'm like, well, what number is that? Because you're looking for 2, so make sure you're very thorough with your variables. There.
Oh, shoot. No. He cancels both of them. So you can't avoid it. Is he called up? I hope I did this right. And so then you
4, 2. Is that what we got? Okay, number 6. Go ahead, try number 6. You see that fraction in that top equation. What are we going to do? Multiply everything by 2. Very good. We'll actually help you out quite a bit in there. So you guys try to take on number 6. Try to take on number 7. We will set up number 8, and then I'm going to show y'all's Delta Math for today. I'm very close to being done with this lesson, and I'm going to let you guys work, and I can come around and help. I worked out number 6. Got the solution 9, -6. Agree?
Yep.
Agree. Okay, I've got work here too. You can come look at it if you need to. On number 7, again, that one was set up for elimination. Yes?
Why is there on the second part, why is there a plus 2? Not like on 7. Why is there a plus 8y again?
Because I had to multiply this, and I chose to eliminate x. Let me put that. I was eliminating x, and I had a -2, needed to turn it into a -4. So I just multiplied everything. That became -4. Oh. Yes. Yes, thank you. Yeah. Good to know. Thank you. -8y. You are correct. Otherwise, it wouldn't. What? Yeah. Okay. So, hey, quiet down. Quiet down. Shh. While y'all getting a seating chart. Hope you enjoyed. Okay. All right. So thank you for catching that mistake. So it is supposed to be -8y. Now, what happens? This wouldn't happen if you would have told me I did that wrong. What happens here? What is 4x minus 4x? 0. What is 8y minus 8y? 0. Put that 0 there. Okay. What happens on the other side? The same thing. So remember, in substitution, we said if the variable drops out, you look at what's left over. In elimination, you're going to get one of those weird cases if both variables drop, but it is very important that you look at what's going on with the constants. Is 0 equals 0 a true or false statement? True. This is true. So what is the answer to this? All or infinite solutions. But if you had 0 equals 10, that would be the no solution. Could I have looked at that equation and figured that out without doing work? Which you wouldn't do because you always show your teacher your work. But how do you know? What does it mean if you do have an infinite or all solution? What's true about those two lines? They're the same. And if you look at those, they have, other than the opposite signs, they are the exact same equation. And that's why it was a no solution. I'm sorry, an all solution. A no solution, you would have very similar, but they would have different y-intercepts. So let's set up number 8, and then I'm going to let you guys get to Delta Math. If you are working on, actually, we kind of need to talk about this one. We might start this one, because I think it's a little bit trickier to do at the beginning. But you've got a situation, you're going to get food or something like this. So what are our variables? Variables, letters. What are our letters? Hamburgers, so y'all want to use H? Okay, and fries. Okay, now, this one's a little bit different, though, because you're not looking for the number of hamburgers, because you're already given those. You're looking for the cost of them, okay? So kind of think about that. This is the hamburger cost, and this is the French fry cost. So our first sentence is going to tell us how to write our first equation. What is it? 3h plus 2 fries, 3 orders of hamburgers, 2 orders of fries is equal to 610. Okay? This is our money equation because remember, our variables are representing the cost of a burger. You already know how many you're getting. You're trying to find the cost. That's one equation. The other one is your friend's order, which is 4H 3F
Plus 840.
equals 840. Okay? I think this is fairly easy to set up. There's not a lot of tricks with this. However, solving. So listen here, because we didn't see an example like this, and you're probably going to see an example like this on Delta Math, and I know for sure next class. Okay? You need to figure out which variable to eliminate. Can you turn a 3 into a 4 by multiplying by a whole number? Can you turn a 2 into a 3 by multiplying by a whole number? So this is a situation where I feel like this is kind of the highest level of elimination. You are going to have to multiply both. So do y'all want to work with 3s and 4s or 2s and 3s? Okay, so that's easier. We're going to eliminate F. So here's kind of I don't want to say it's a trick because it's really not, but if you need to multiply both equations, you can kind of do this little crisscross thing. I can multiply the top equation, I'm taking out F, by the coefficient of F in the bottom equation, which is a 3. What is 3 times 2? 6. On the bottom, I can multiply that equation by the coefficient of F on the top. What is 2 times 3? 6. Y'all see that kind of crisscross thing? I'm taking this guy out so you can multiply by this and this. But what do you have to do to make them knock out? One of them has to be negative. You pick. Whatever. Okay? So you can go through and solve that. I will get the word problem solved. I will say with word problems, make sure that you're answering what it's asking you to answer. For instance, it doesn't just want the solution. This is a hint, warning, might put a star. Not just the solution and stop. This is saying you have to find the solution and then tell me how much it's going to cost to get 1 hamburger and 1 fries. So a little bit of an extension. It's not hard, but you have to find those numbers and then put them into another equation. You might want to practice doing that. Okay? Let me show you your Delta Math real quick here, and then I'm going to... So here's your Delta Math for Unit 1. Remember, this is a growing situation. So I don't want you to come in here on Tuesday and be at 100%. Not yet. I only want you to go through 1.1. So you'll look, that's 4 questions in the first section. Those are just like straight, they alternate between, I don't even know alternate. You're going to get some substitution, some elimination. But then look at these 2 right here. I want you to look and make sure you know what you're doing. One of my biggest pet peeves is answering the same question 50 times. Okay, so listen, and then I'm done. These kind of singular questions, these are from your notes. So it says to go to section 1.4. Remember, that's at the back of the packet. It starts on page 21. You might want to write that down. And it actually wants you to work the word problem on page 21. Number 1, work it out, and then go and put the answers in. How it says check your solutions, you don't know how to do that yet, so don't worry about it. Just do substitution or elimination, and then you go answer the question here. It will tell you if you get it wrong, so you know. So there's 2 of those. So 4 randoms, 2 from the notes, and I believe both of these are on page 21. It's word problem practice. That is your homework for next class. Remember, we've got a mid-unit assessment, not next class, but the next. This is about half of it, is 2 variable systems, Algebra 1 style. Okay? All right, now you work.